In the last video, we looked at converting from polar to Cartesian. In this particular video, we're going to go the other way and convert from Cartesian to polar. In the first video, I introduced the following. We had x is equal to r cos theta, y is equal to r sine theta. We had r was equal to the square root of x squared plus y squared, and r squared was given as x squared plus y squared. And we also introduced the idea, not that we're going to use it here, that theta was equal to the inverse tangent of y over x. Okay, generally with these, I've not looked at them yet, but generally they're quite, they force you into a bit of work. So don't be afraid to get them wrong, just start again. But the majority of it is either trig identities or just manipulation. So let's look at the first one. X squared plus y squared is 16. Well, x squared plus y squared is r squared. So we can say now r squared is equal to 16. We know that r is a positive value, so we can write r is equal to 4, and we have a circle, centre 0, 0, radius of 4. Okay, so nice and straightforward. All I've done is swapped x squared plus y squared is equal to r squared from my table over here. Okay, next one, xy is equal to 4. So x is r cos theta, y is r sine theta. So if we multiply those two, we're going to get r squared sine theta cos theta is going to be equal to 4. Not blindingly obvious. What I'm going to say then is r squared over 2 is going to be sine 2 theta will be equal to 4. Just consider sine theta cos theta is 1/2 sine 2 theta. So multiplying both sides by 2, dividing both sides by sine 2 theta, we're going to have, what's that, 8 over sine 2 theta. So we can say r squared will be 8 cosec 2 theta. And as you can see, they're not always, you might have wanted to have gone the other way and just divided through by this first and then gone with that approach, and just written it as r squared is 4 over sine theta cos theta and manipulated from there. It's entirely up to you, but as you can see, they often take a little bit of messing about. Okay, x squared plus y squared all squared. Well, x squared plus y squared is r squared, so that's going to be r to the 4th. So we're going to have r to the 4th is going to be equal to 2xy. So what I've got now is 2r cos theta, and then multiplied by r sine theta. So we can say r to the 4th is equal to 2r squared cos theta sine theta. So dividing through by r squared, we can have r squared is equal to 2 sine theta cos theta, or we can simply say now r squared is equal to sine 2 theta. So again, a bit of manipulation, but fairly logical. Right, let's have a look at the next one. X squared plus y squared minus 2x. Well, let's write this now as x squared plus y squared is equal to 2x. X squared plus y squared is r squared. X is r cos theta, so we have 2r cos theta. And then dividing through by r, we're going to get r is equal to 2 cos theta. Okay, and that will give us another circle. So that's fairly straightforward. This one, let's have a think on this one. X squared plus 2xy plus y squared is going to be equal to 4. Now consider x squared is r cos theta, or r squared cos squared theta, and then we've got now y is equal to r squared sine squared theta. What we can write then is r squared, and we're going to have cos squared theta plus sine squared theta. Well, that's just going to be equal to 1. So if we think about this here, we've got 2xy, so that's going to give us, and that will give us 2r cos theta r sine theta, or 2r squared, and then we're going to have cos theta sine theta, or we could say r squared sine 2 theta. So after that bit of messing about, and I'm sure that can be done a slightly quicker way, so I'm happy to say, happy if you've got a better way of doing that one. This is going to give us 1, isn't it? Cos squared theta plus sine squared theta is 1. So what we've got then is r squared plus r squared sine 2 theta is equal to 4. What can we do? We can factor the r squared, can't we? So we can write now r squared 1 plus sine 2 theta is equal to 4. So r squared is equal to 4 over 1 plus sine 2 theta. On reflection, I think I could have done that one a bit better, but that certainly gets us where we want to be. Right, let's look at another one. X minus y is equal to 3. Okay, well, x is r cos theta, so r cos theta, and then we've got minus r sine theta is equal to 3. If we factor out the r, what we've got is r, then we've got cos theta minus sine theta is equal to 3. I think we're going to need a trig identity for this one. If we consider the following, let's look at cos of pi. What are we going to have? Theta plus pi by 4. If I expand this, what I'm going to get now is cos theta, cos of pi by 4, which is 1 over root 2. Then I'm going to get minus sine theta, sine of pi by 4, which is going to be 1 over root 2 sine theta. So what we can say here is we could rewrite this now, just looking at it now. We've got root 2, so we could write this as now r over root 2, and then we could say cos of pi by 4, that'll work, is going to be equal now to what are we going to have on this side. We're going to have to, let's just think how we can manipulate this. In fact, let's rewrite this. Let's write it in this way. Let's write, I'll think of a better way of doing this. So we're going to have now r cos theta plus pi by 4, and then we can write root 3 over 2. That would be more logical. Hopefully that makes sense. I'm thinking that's going to work. If it doesn't, I'm going to apologise in advance, but that looks pretty good to me. So all we've done is use a trig identity. So now what I'm going to do is divide through by cos of pi by 4. So we can now write this as 3 over root 2. And then what's that going to be? Sec, isn't it? Sec of pi, theta plus pi by 4. So often you'll need these little, just little silly, well, I say silly little things, quite intricate trig identities, and if you can spot that, that's really quite helpful. To be honest, I doubt that you'd get that in the exam based purely on that. So let's look at another couple of these while we're here. Okay, so y is equal to 2x, so r sine theta is going to be equal to 2r cos theta. Let's divide both sides by r cos theta, so r sine theta over r cos theta is going to be equal to 2. The r's will cancel. Sine theta over cos theta is tan theta, so tan theta is equal to 2, or theta is going to be the inverse tangent of 2. That one's fairly straightforward. Right, let's have a think about this one here. Let's rewrite this one then. Let's say y is equal to r sine theta, and then what we're going to have, r sine theta is going to be equal to negative root 3 r cos theta, and then we're going to have plus a. So let's bring all of this together. Let's write this as r sine theta, and then we're going to have the plus root 3 cos theta, and I think we're going to need to use another one of those trig identities. So let's have a look at this. What's that? Let's try and expand sine of theta plus pi by 3. If I expand that, I'm going to get sine theta cos of pi by 3, which is going to be 1/2. And then what we're going to have now is plus, what we're going to have, cos theta, and then sine of pi by 3 is going to be root 3 over 2. So that gives me that, and that looks pretty good. If you're not sure of that, just hit pause and have a mess about with that. But I think that's going to look pretty. That's going to look pretty good. So what we can now say then is, if we write this as r, and then we can say sine of theta plus pi by 3 is going to be equal to, what can we write that now? A over 2. Does that look good? A over 2. So to finish that one off, we can now write this as r is equal to a over 2, and then we're going to get cosec of theta plus pi by 3. I think that should work. I'm pretty sure that's good. But as you can see, it's just a bit of manipulation and just messing about. And if you can spot these, I'm kind of assuming that you've done C3 and you can work with them. But I would expect if you're given anything, it will be more in the range of getting a circle rather than any of these sort of intricate lines as such, like these, because they are quite fiddly. But there we go. That's converting from Cartesian to polar form. So hopefully I've not been too sketchy as I've been going, because I've been doing it off the top of my head, but that should give you some idea.